Okay, so the drag force acting on an object falling through air is given by this equation. Perfect. Where A is the cross sectional area, V is the velocity, rho is the density, C is a constant called the drag coefficient. Perfect, perfect. Determine the SI base units to show that the drag coefficient has no units. Okay. बेटा हमने SI बेस यूनिट्स को यूटिलाइज करके ये शो करना है दैट ड्रैग कोफिशिएंट हैज नो यूनिट्स. How will we do that? How will we do that? First of all, do you remember that force has units of what? Mass into acceleration kg, and acceleration has units of what? ms minus 2. तो बेटा ड्रैग फोर्स के क्या यूनिट्स हो जाएंगे? kg ms minus 2. We will ignore 1 upon 2. Why? Because whenever we are doing calculations related to units, we ignore the constants. Then we have this drag coefficient C. Let's write it capital C like this. Perfect. Then we have density. That is what? kg m minus 3. Perfect. Then we have area. Area के units क्या होंगे बेटा? मीटर स्क्वायर. Perfect. Then we have velocity. What will be the units of velocity? ms minus 1 whole square. Perfect. Is anything getting cancelled out? Beta, is anything getting cancelled out? Yes. kg cancel out. Perfect. ms minus 2 is equals to capital C m minus 3 into m square into m square s minus 2. I have multiplied the square. So what are your units becoming out? By ms minus 2 is equals to capital C meter minus 3 plus 2. This becomes meter second minus 2. Can you realize? Can you realize this ms minus 2 gets cancelled out with this ms minus 2? C has no units. C has no units. Is this thing clear? Yes or no? Is this thing clear, beta? ये बात क्लियर हुई? yes or no? Tell me in the chat. Yep. क्लियर नहीं है बताओ, क्लियर है बताओ. If there is anything that is troubling you, बताओ. आगे बढ़े भाई. चलो let's further move ahead. Let's further move ahead. One second, what do we have here? चलो clear है. Perfect. Okay, figure 1.1 shows a sphere falling at terminal velocity in air. By terminal velocity, what hint is the examiner giving us? बेटा terminal velocity हमें क्या hint दे रही है? That the object is falling at constant velocity. If an object is falling at constant velocity, what does that mean? Upward forces will be equal to the downward forces. बेटा अगर एक ऑब्जेक्ट कांस्टेंट वेलोसिटी पे फॉल कर रहा है दैट मींस अपवर्ड फोर्सेस विल बी इक्वल टू द डाउनवर्ड फोर्सेस. परफेक्ट. लेट्स फर्दर मूव अहेड. यू कैन आल्सो राइट इट हियर अपवर्ड फोर्सेस इज इक्वल टू द डाउनवर्ड फोर्सेस. ठीक है. Assume that the upthrust on the sphere is negligible. Okay, upthrust is negligible. On figure 1.1, draw and label arrows to show the direction of the two forces acting on the sphere. बेटा फर्स्ट ऑफ ऑल स्फीयर पे क्या कर रही होगी? उसका वेट. सेकेंडली, इफ यू आर फॉलिंग थ्रू एयर, what will be the resistive force? Air resistance acting backwards. अब यहां पे मैंने constant velocity लिख दिया बेटा. That's troubling me. You have to make sure, you have to take care of one more thing. Why are there 2 marks here? You have to make sure one more thing, that the size of the air resistance ka arrow is the same as the weight. Simple. Let's further move ahead. The mass of the sphere is this. Calculate the drag force acting on the sphere. Okay, we are given the mass. We have to calculate the drag force. How can we calculate the drag force? Any ideas? We know that the air resistance or the drag force in this case is equals to the weight. What is weight equal to? Mass into g. What is mass? 49 grams को divided by 1000 कर दो. Multiplied by g, that is 9.81. Can you calculate the drag force भाई? Can you guys calculate the drag force? Calculators हैं सबके पास या सारे सिर्फ मूवी देखने आए हुए हैं? Can you calculate the drag force here? Yes, the drag force comes out to be 0.48 Newton. And one more thing, beta, it would be appropriate to mark this as drag force and not air resistance. Why? Because question में देखो drag force का ही जिक्र हो रहा है. The drag force acting on an object falling in air. So drag force is the force acting on an object falling in air. So I would suggest कि air resistance यहाँ पे ना mark करो, drag force ही mark करो. And here as well, air resistance का symbol हटा दो. Remove the air resistance का symbol. Perfect. चलो, let's further move ahead. The sphere is falling at a terminal velocity of 25 in SI base units. Perfect. The density of the air 1.2 in SI base units. The diameter of the sphere is this in SI base unit. Use your answer in C to calculate the drag coefficient C for the sphere. Very very easy. अच्छा किसी का सवाल है? सर व्हाट इज द डिफरेंस बिटवीन अपथ्रस्ट एंड ड्रैग फोर्स? बेटा बहुत बड़ा डिफरेंस है, बहुत बड़ा डिफरेंस है. Upthrust acts due to what? Upthrust acts due to change in pressure. और ड्रैग फोर्स तो एक रेजिस्टिव फोर्स होती है. ठीक है. Upthrust basically acts due to your change in pressure of the top and bottom surfaces. Upthrust basically acts on an object due to the change in pressure on the top and bottom surfaces. और ड्रैग फोर्स तो एक रेजिस्टिव फोर्स होती है. ओके. Now here, what is the formula of drag force? Fd is equals to, let's write it here, Fd is equals to 1 over 2. What is the formula? CPAV square. Okay, C rho A V square. Do you know the drag force? Yes, 0.48. Perfect. Half. We don't know the drag coefficient. Let's put a C here. Do you know the density? We know the density 1.2. Perfect. Do we know the area? No. But we know the diameter. What can we do? We can say area is equals to pi over 4 into diameter ka square 6.06 square multiplied by velocity ka square, that is 25 ka square. Can you calculate this value of C, beta? Yes, you can easily calculate the value of C. 0.48 into 2, 4 also gets multiplied there, divided by 1.2 pi into 0.06 square into 25 ka square. Can anyone calculate this answer, bhai? Can any genius in the chat calculate this answer and tell me the correct answer? What does the drag coefficient comes out to be? 0.45. Is this entire question clear to all of you, bhai? Question clear hai ye wala? Yes or no? Tell me in the chat. Define velocity. Okay, what is velocity? I am just watch. Very good. Very good. Very good. Define velocity. What is velocity? Velocity is displacement. Rate of change of displacement. You can write that. Velocity is rate of change of displacement. Perfect. Let's see the next question. A student throws a ball over a vertical height h. Perfect. As shown in figure 2.1. Perfect. The ball leaves the hand of the student at a height of 1.2 meters. ठीक है भाई, बॉल जो है वो लीव कर रही है स्टूडेंट का हैंड एट अ हाइट ऑफ 1.2 meters above the horizontal ground. The ball has an initial velocity of 22 at an angle of 40 degree to the horizontal. Perfect. The ball The wall is a horizontal distance of 36 meter. Okay, this is 36 meter from where the student releases the ball. Air resistance is negligible. What does this tell us? This tells us that acceleration is 9.81 ms minus 2. Determine the time taken for the ball to reach the wall. Perfect, perfect. We have to determine the time taken for the ball to reach the wall. First of all, can I zoom in and can I break this 22 ms minus 1 ki velocity into two vectors? Yes. One can be the horizontal vector, that is 22 cosine 40, and one can be the vertical vector, that is 22 sine 40. Perfect. These are the two vectors in which the velocity can be broken down. Perfect. Now, if you remember the horizontal component of velocity, if you remember the horizontal component of velocity in projectile motion used to remain same. Beta, if you remember the horizontal component of velocity in projectile motion used to remain same. तो बेटा ये velocity का component आ गया आपका, ये distance आ गया. Can you calculate the time? Yep, you can do that. Your velocity is 22 cos 40. Distance is 36 meter. Can you calculate the time? Yes. Which formula will we use? Distance is equals to velocity into time. Distance 36 है बेटा, velocity से divide कर दो 22 cos 40. What does your time comes out to be? Time क्या आ जाता है? Anyone in the chat? Any geniuses? Although you don't require to be a genius to solve this. Time आ जाता है 2.1 seconds. 2.1 seconds is your answer. चलो, let's move ahead. Let's move ahead. Okay, calculate the vertical component u of the initial velocity of the ball. We have already done that by vertical component क्या है? Velocity का 22 sin 40. Let's write it here. 22 sin 40. What does this come out to be? Yes बेटा, ये किसके इक्वल आ जाता है? 14 ms minus 1. The ball just goes over the wall. Calculate the height h of the wall. A very, very interesting question. You have to calculate the height h of the ball when the ball goes over the wall. अच्छा बेटा, फर्स्ट ऑफ ऑल तो मुझे बताओ, अभी तक सारी चीजें क्लियर है? यस और नो? इज एवरीथिंग क्लियर अप टिल नाउ? इस सवाल में अभी तक सारी चीजें क्लियर है? क्योंकि नेक्स्ट सवाल थोड़ा सा इंटरेस्टिंग है. यू हैव टू कैलकुलेट द हाइट. पिछला वाला सारा क्लियर होना चाहिए टू नो दिस. ओके, नाउ just focus a bit. Just focus a bit. Your vertical velocity is 22 sine 40. Perfect. This is your initial vertical velocity. Initial vertical velocity. Perfect. You have to calculate this height h. Perfect. But let's assume just for a minute. Let's assume this red line is your level ground. ये assume कर लेते हैं बेटा. Let's assume this is your level ground. ठीक है, ये आपका ग्राउंड लेवल है. just for a minute assume this कि ये level ground है. Can you calculate this displacement? Can you calculate this displacement if I assume that this red line is a level ground? Yes, you can do that. किस तरह करोगे? If you want to calculate this yellow highlighted displacement, how will you do that? You will apply S is equals to ut plus half atu square in the vertical direction. You will apply S is equals to ut plus half atu square in the vertical direction. Perfect. Do you have the time? Yep, 2.1 seconds. Do you have the u? Yes, 22 sine 40. Do you have the acceleration? Yes, 9.81. So you can actually calculate this yellow highlighted distance. You have the u in the vertical direction, that is 22 sine 40. You have the time, that is 2.1 seconds. बेटा acceleration भी आपके पास है. You have to just do one thing to the acceleration. You have to understand that upward vectors are positive, downward vectors are negative. Acceleration due to gravity बेटा कहाँ act करती है? Acceleration due to gravity acts downward. This 9.81 acts downward. So this will be actually negative 9.81 ms minus 2. So your acceleration is negative 9.81 ms minus 2. ऑल क्लियर अप टिल नाउ? बेटा एक्सेलरेशन को मैंने नेगेटिव 9.81 ms माइनस 2 क्यों लिखा है? डू यू अंडरस्टैंड दिस? डू यू अंडरस्टैंड व्हाई हैव आई रिटन एक्सेलरेशन एज नेगेटिव 9.81 ms माइनस 2? यस और नो? हम्म. Yep. Do you understand this? Why have I written acceleration as negative 9.81 ms minus 2? Because beta acceleration due to gravity acts downwards. And we have assumed that downward vectors will be negative, upward vectors will be positive. हमने assume कर लिया है कि downward vectors negative होंगे, upward vectors positive होंगे. That's why acceleration due to gravity is negative 9.81 ms minus 2. हो गई बात क्लियर अप टिल नाउ? यस और नो? डू यू गाइस गेट इट बेटा? मैंने एक्सेलरेशन ड्यू टू ग्रेविटी को नेगेटिव 9.81 क्यों लिया है? यस और नो? बताओ जरा. यप, चलो अल्हम्दुलिल्लाह. नाउ लेट्स अप्लाई s इज इक्वल टू ut प्लस हाफ ए टी स्क्वायर बाई. s इज इक्वल टू u क्या है? 22 साइन 40. टाइम क्या है बेटा? 2.1 प्लस हाफ इंटू एक्सेलरेशन क्या है? नेगेटिव 9.81 इंटू टाइम क्या है? 2.1 होल स्क्वायर. कैन एनी वन कैलकुलेट दिस एस? कैन एनी वन कैलकुलेट दिस डिस्प्लेसमेंट या एस? यप. कैन एनी वन डू दैट? कैन एनी वन कैलकुलेट दिस डिस्प्लेसमेंट एस? एनी जीनियसेस? This displacement s comes out to be 7.8 meters. This displacement s comes out to be 7.8 meters. That means beta ये yellow portion कितना है? 7.8 meters. You have to calculate the total height. The total height also includes this green wala portion, that is 1.2. So h will be equal to what? 7.8 plus 1.2 meters. This comes out to be 9 meters as your answer. You can take all of this in the working below. नीचे working में ये सारी चीजें लिख सकते हो. Let's write it here. Perfect. Now let's see this one. Acha. State the principle of conservation of momentum. Who will tell this in the chart? What is principle of conservation of momentum? बेटा principle of conservation of momentum क्या है? Yep. What is the principle of conservation of momentum? The total momentum before collision is equals to total momentum after collision given that there is no external force. ओके 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 ओके. क्लोज्ड स्पेस नहीं लिखते बेटा, क्लोज सिस्टम लिखते हैं अगर आपने लिखना है वो तो. यू विल से अगर, चलो लेट्स राइट दिस. द टोटल मोमेंटम बिफोर collision is equal to the total momentum after collision is equals to the total momentum after collision given that no external force acts on the system. Acts on the system. Perfect. Chalo, let's further move ahead. लेट्स फर्दर मूव अहेड भाई, आगे बढ़ते हैं. An object of mass 2m is traveling at a speed of what? 5 ms minus 1. Perfect. An object of mass 2m is traveling at a speed of 5 ms minus 1 in a straight line. It collides with an object of 3m which is initially stationary as shown in figure 3.1. Perfect. So beta, initially this object is stationary with a mass of 3m. This object has a mass of 2m traveling with a velocity of 5 ms minus 1. Perfect. After the collision, the mass of 2m moves with a velocity v at an angle of 30 degree to its original direction of motion. Perfect. The object of mass 3m moves with velocity w along at an angle of 30 degree as shown in figure 3.2. Perfect. What do you have next? By considering the conservation of momentum in two dimensions, calculate the magnitude of v and w. Perfect. We have to calculate the magnitude of v and w. How are we going to do that? बहुत easy. Let me see how many marks we have. 4 marks. Perfect. So beta चलो start करते हैं अपनी working. First of all, let's apply principle of conservation of momentum in the horizontal direction. Let's write here principle of conservation of momentum in horizontal direction. In horizontal direction. Perfect. Now, if you apply principle of conservation of momentum in the horizontal direction, what will be the momentum before collision? What will be the momentum before collision? The momentum before collision is what? Mass of 2m multiplied by the velocity of 5. 2m into 5. Plus mass of 3m multiplied by the velocity of 0. This will become zeroed out. The momentum before collision equals to what? 10m. Perfect. Now let's calculate the momentum after collision. Let's calculate the momentum after collision. एक सेकंड भाई. अच्छा वी निकाल भी ली भाई मुइज ने. वेरी गुड यार, वेरी गुड. लेट मी चेक. नहीं, वी गलत आ रही है. वी इज रॉन्ग. थोड़ा सा और प्रैक्टिस करो. सी यू माइट हैव मेड मिस्टेक समवेयर, लेकिन ये अच्छी बात है. यू गाइज आर डूइंग इट खुद से. Now, if you notice, after collision, what is happening? This object 2m is moving with a velocity of v. Can you calculate the horizontal component of this velocity v? Yes, this will be v cosine 30. And this mass of 3m is traveling with a velocity of w. Can you calculate the horizontal component of w? Yes, w cosine 30. Can you calculate momentum after collision? Yes. Mass of 2m into v cosine 30 plus mass of 3m into w cosine 30. Perfect. Now, can you do one thing? Can you equate the total momentum before collision to the total momentum after collision? Yes, we can do that. Let's do that. Let's do that. 10m is equals to 2m v cosine 30 plus 3m w cosine 30. What will we do here? If you see, all the terms have m common, so m will get neglected. ठीक है, अब v और w में equation बनानी है. How can we make an equation? What we can do is 10 is equals to 2v cosine 30 plus 3w cosine 30. Let's bring this 3w cosine 30 towards the left hand side. This will become what? 10 minus 3w cosine 30 divided by 2 cosine 30 is equals to your v. This is your first equation, beta. Is the first equation clear to you guys? पहली equation clear है? Yes or no? Is the first equation clear to you guys? Yes or no? Now let's apply principle of conservation of momentum in the vertical direction. Now let's apply principle of conservation of momentum in the vertical direction. Where should we put this? इसको हम यहाँ पे put in कर देते हैं चलो. Let's apply principle of conservation of momentum in the vertical direction. Let's do that. Okay, let's apply here. Principle of conservation of momentum in vertical direction. In vertical direction. If you observe, if you observe, initially both of these masses have no vertical velocity. So the momentum before collision in the vertical direction will be 0. The momentum before collision in the vertical direction will be 0. Let's calculate the momentum after collision in the vertical direction. So let's zoom in a bit here. If you focus, what are the vertical velocities? This one, that is v sine 30, and this one, that is w sine 30. Perfect. Now one vertical velocity is acting upward, one is acting downward. What can we do here? We can create axes. Upward as positive, downward as negative. Perfect. Can you calculate the momentum after collision, beta? Yes. The mass of 2m multiplied by this vertical velocity, that is v sine 30, plus the mass of 3m, and this velocity w sine 30 is in the downward direction. So negative w sine 30. Can we equate both of them? Yes, we can equate both of them. You can equate momentum before collision to the momentum after collision. Beta equate कर दो चलो शाबाश. This equals to 2m v sine 30 plus. Sorry, we will put a negative here because the negative inside comes on the outside. Negative 3m w sine 30. What can you do here? You can take m common and cancel that out. And then you can take this entire term on the left hand side. Take this entire term on the left hand side. 3w sine 30 is equals to 2v sine 30. Can we make v the subject of the formula here as well? Can we make v the subject of the formula here as well? 3w sine 30 divided by 2 sine 30 is equals to v. This cancel out. 3w upon 2 is equals to v. This is your second equation. Is this clear or not? बेटा दोनों इक्वेशंस क्लियर हो गई. मुई जारियान रुबीसा बेटा इससे डिटेल में प्रिंसिपल ऑफ कंजर्वेशन ऑफ मोमेंटम इन 2 डायमेंशन कैन नॉट बी एक्सप्लेन. ये बात क्लियर हो गई बेटा. जारियान मुइज बेटा इज इट क्लियर? अब सिर्फ हमने v और w निकालना है. अब सिर्फ हमने v और w कैलकुलेट करना है. ओके, लेट्स डू दैट. लेट्स डू दैट. किस तरह करेंगे? यप, किस तरह करेंगे? वी विल यूज साइमल्टेनियस इक्वेशंस भाई. इक्वेट इक्वेशन 1 टू इक्वेशन 2. भाई इक्वेशन 1 में भी v है, इक्वेशन 2 में भी v है. इक्वेट बोथ ऑफ देम टुगेदर. व्हाट आई वुड प्रेफर टू डू हियर, चलो यहाँ पे ही कर देते हैं. लेट्स डू इट. सॉल्व simultaneously. Solve simultaneously. 10 minus 3w cosine 30 divided by 2 cosine 30 is equals to 3w over 2. Cross multiply it beta. 2 into 10 minus 3w cosine 30 is equals to 2 cosine 30 multiplied by 3w. This becomes 20. This becomes 6W cosine 30 is equals to 6W cosine 30. Let's bring this negative 6W cosine 30 to the left hand side. Chalo. 20 is equals to 6W cosine 30 plus 6W cosine 30. 20 is equals to 12W cosine 30. 20 divided by 12 cosine 30 is equals to W. Can any genius calculate W? भाई बहुत बड़ा क्वेश्चन था ये. This was a very lengthy question. Anyone can calculate this answer भाई? 12 cosine 30. This comes out to be 1.92. W comes out to be 1.92 ms minus 1. Perfect. Can we calculate V? Yes, V calculate करना further easy था. How can we calculate V? V is equals to 3W over 2. V is equals to 3W over 2. 3 into 1.92 divided by 2. बेटा आंसर क्या आ जाएगा? What will your answer come out to be? 2.9 ms minus 1. So these are your final answers. W is equals to 1.92 and V is equals to 2.9 ms minus 1. All clear? Yes or no? Tell me in the chat. हाँ भाई. अच्छा नेक्स्ट पार्ट्स इजी है. नेक्स्ट पार्ट्स इजी है. नेक्स्ट पेपर भी पूरा इजी है. लेट्स सी दिस. An object an object of mass 4.2 kg is traveling in a straight line at a speed of 6 ms minus 1. The object is brought to rest in a distance of 0.5 meters by a constant force. Calculate the magnitude of this force. कितना easy है ये? You have your initial speed that is 6. You have your distance that is 0.05 meters. You are bringing it to rest. Final speed 0. Can you calculate the acceleration? Yeah, deceleration. Yes. Which formula of kinematics will we use here? V square is equals to U square plus 2AS. V क्या है भाई 0. U क्या है 6 square plus 2 into acceleration we don't know into the distance that is 0.05. Let's take this to the other side. Negative 36 divided by 2 into 0.05 is equals to your acceleration. Calculate कर लो भाई. 36 divided by 2 into 0.05. This comes out to be 360. Negative 360 ms minus 2 is your deceleration. ठीक है. Negative 360 is your deceleration. Perfect. अच्छा. अब आपने फोर्स निकालनी है. You have to calculate the force भाई. How will you calculate the force? फोर्स ही निकालनी है ना. यहाँ we have to calculate the force. How will we do that? Force is equals to ma. मास क्या है भाई 4.2. एक्सेलरेशन क्या है 360. Multiply it. 4.2. This answer comes out to be 1512 Newton. This is your stopping force. यस बेटा. इज दिस क्लियर भाई? आगे बढ़ते हैं. चलो ये बड़ा ही अच्छा सवाल था. लेट्स फर्दर मूव अहेड. डिफाइन स्ट्रेन. व्हाट इज a strain भाई? What is a strain? Extension over the original length. Extension divided by original length is your strain. Extension over original length is your strain. Simple. A copper wire of length this. Okay, so you are given the length. Has a uniform cross sectional area of this. Perfect. A tensile force is this. Perfect. Length area force. This causes the wire to extend by 1.5 millimeter. This is the extension. You have to calculate the Young's modulus. Any geniuses who can tell me how will I do this? Beta, dekh rahe ho? Now, a copper wire has a length of 4 meter, uniform cross sectional area of this, force of this, and extension of this. You have to calculate Young's modulus. So easy. Literally the easiest question that you will have in AS. So let's do that. Your force is what? 18. Length is 4. Area is what? 4.5 into 10 raised to the power of minus 7. Extension is 1.5, 1.4 millimeter. So you will have to convert it into meters by multiplying with 10 raised to the power of minus 3. What does your Young's modulus come out to be? What does your Young's modulus come out to be? 1.1 into 10 raised to the power of 11 pascals is your Young's modulus. All clear? One second, bhai. Shabash, Mo is very good. Yeah, this is your Young's modulus. Let's see this. On figure 4.1, draw a line to show how stress varies with strain for the wire up to its limit of proportionality. Okay, you have to draw the stress versus strain graph for this wire. How can you do that? How can you do that? Uh, sir, don't we have to convert meter square to meter? कहाँ पे है मीटर स्क्वायर भाई? कहाँ पे है? नो बेटा एरिया तो मीटर स्क्वायर में ही होता है ना. व्हाई विल यू कन्वर्ट इट इनटू मीटर्स? नो 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 ना नो. अच्छा, we have to draw the stress strain graph. How will we draw the stress strain graph? First of all, we know that the stress strain graph starts from origin. This will be your first point. Perfect. Then, can we calculate the stress for this copper wire? Yes. Stress is equals to force over area. What is force? 18. What is area? 4.5 into 10 raised to the power of minus 7. Can anyone calculate the stress here? Yep, geniuses. Can you calculate the stress here? The stress comes out to be 18 divided by 4.5. This comes out to be 4 into 10 raised to the power of 7. This is your stress. Can we calculate the strain? Yes, we can also calculate the strain. Strain is equals to what? Extension over length. Extension is what? 1.4 millimeter. Perfect. Convert it into meters. What is the length? Length is 4 meters divided by. This comes out to be what? 1.4 into 10 is the power of minus 3 divided by 4. This comes out to be 3.5 into 10 raised to the power of minus 4. So you have the strain as well, beta, and you have the stress as well. Can you plot this on the graph? Can you plot this on the graph? Yes. स्ट्रेस के लिए आपने 4 ले लिया, स्ट्रेन के लिए आपने 3.5 ले लिया. दिस इज योर सेकेंड पॉइंट. कैन यू ड्रॉ अ ग्राफ बिटवीन दीज टू लाइन्स? यप, somewhat like this. This is your graph. Perfect. Let's further move ahead. A second wire has the same length as the wire in B, but has a larger diameter. Both wires are subjected to the same force. Perfect. By placing a tick in each row, complete table 4.1 to compare the stress and strain of the two wires. Perfect, perfect, perfect. Just listen carefully what is happening. A second copper wire. That means what? Young's modulus is same. Same length as well, but a larger diameter. Okay. If you have a larger diameter, what will happen to the stress? If you see, stress is equals to force over area. And you can replace area ka variable with what? Area is equals to pi over 4 d square. Multiply 4 to the top side. 4f pi d square is equals to stress. Can you see the stress and diameter are inversely proportional? So if the second wire has a larger diameter, the stress in the second wire will be less. The stress in the second wire will be less. less. What about strain? Strain is equals to what? Extension over length. The length of the second wire is the same as the length of the first wire. But what will happen to the extension? Or leave alone this. There is another easy way to do this. Can you realize Young's modulus E is equals to stress over strain? Young's modulus E is equals to stress over strain. Beta, both the wires have the same Young modulus because both of them are made of the same copper material. If both of them have the same Young's modulus, that means what? Strain is directly proportional to stress. If stress is less in the second wire, the strain will also be less in the second wire. This is your answer. Is it clear or no? Okay, let's see this. A stretch spring PQ has a length 1.2 meters perfect. One end of the string is attached to a vibration generator and the other end is attached to a wall perfect, as shown in figure 5.1 perfect. The vibration generator is switched on and a stationary wave is formed on the string. The string is shown at one instant of time in figure 5.2. Perfect. Explain how a stationary wave is formed between the vibration generator and the wall. Now, this is an FAQ. This is an FAQ of the examiner. How a stationary wave is formed between the vibration generator and the wall. If I was you, I would have written this in a register or somewhere important because this gets repeated frequently. What happens? Wave travel from the generator towards the wall. First point that you will write here is wave travel from generator towards wall. What will happen then? Wave travels from generator towards wall. They get reflected at the wall. They get reflected. They get reflected at the wall. They get reflected at the wall. The superposition, the superposition of incident and reflected waves produces stationary waves. Beta, what is happening here? Can any genius in the chat tell me what is happening here? Beta, this vibration generator produces incident waves like this. They hit the wall, they give rise to reflected waves like this. The superposition of both of these waves gives rise to stationary waves. Perfect. Calculate the wavelength of the stationary waves shown in figure 5.2. Perfect. We have to calculate the wavelength. Now just focus on the board. This is a node. This is a node as well. This is a node as well. This is a node as well. In a stationary wave, nodes are the points of minimum displacement. बेटा स्टेशनरी वेव में वो पॉइंट्स जिनकी डिस्प्लेसमेंट मिनिमम होती है आर नोन एज नोड्स परफेक्ट सो दीज आर द नोड्स नाउ व्हाट विल बी द डिस्टेंस फ्रॉम नोड टू नोड हाफ लैम्डा अगेन डिस्टेंस फ्रॉम नोड टू नोड half lambda distance from node to node half lambda the total lambdas will be 3 over 2 lambda this is equals to 1.2 meters lambda will be equal to what 2 into 1.2 divided by 3. This comes out to be what? 2.4 divided by 3, this equals to 0.8. Lambda is equals to 0.8. Let's do this working in the part below. Clear है बेटा ये? Yes or no? Tell me in the chat. Yes. Wavelength निकालना was really easy here. Let's move ahead. Sir, can you tell what is antinode? बेटा antinode is the point of maximum displacement. जैसे ये minimum displacement के points है ना, maximum displacement के points को हम antinode कहते हैं. ये वाली चीज़ है. Simple. ठीक है, चलो आगे बढ़ते हैं. Figure 5.1 shows the stationary wave at time t is equals to 0. When all points on the wave are at their maximum displacement, perfect. The period of the wave is this, perfect. On figure 5.3, sketch the shape of the stationary wave at time t is equals to 0.24 seconds, perfect. Beta, time period क्या है? What is your time period? 0.16 seconds. What will be the position of the stationary wave at a time of 0.24 seconds? भाई स्टेशनरी वेव की क्या पोजीशन होगी एट अ टाइम ऑफ 0.24 सेकंड्स? एनी आइडियाज जीनियसेस? क्या होगी स्टेशनरी वेव की पोजीशन एट अ टाइम ऑफ 0.24 सेकंड्स? If you remember, the time period of a stationary wave was divided into four halves. बेटा स्टेशनरी वेव का टाइम पीरियड फोर हाउस में डिवाइड होता था. लेट मी शो यू एज वेल इन द नोट्स दिखाता हूँ एक सेकेंड, so that you guys can remember this. एक second. Yeah, here we have it. I hope all of you can see the notes. Ah, beta, if you have a stationary wave, the time period gets divided into four. Initially, if the stationary wave is like this, after quarter of a time period, the stationary wave becomes flattened out. After another quarter of a time period, the stationary wave becomes this. After another quarter of a time period, the stationary wave again flattens out. And after a complete time period, a stationary wave returns to its original position. So why is this happening? Because initially the stationary wave is moving downward, this is moving upward. This further moves downwards, this further moves upwards. You reach this sort of a position. Then this starts to move upwards, this starts to move downwards. This further starts to move upwards, this further starts to move downward. You return to the original position. Here, if you notice, here. If you notice, we have a time period of 0.16. Okay, you have to calculate the position at 0.24 seconds. Okay. So 0.24 seconds is basically what? Time period plus time period over 2. So what will happen? In the first quarter of a cycle, the stationary wave will become flattened out. And after a further quarter of a time period, what will happen? The stationary wave will flip. This will be your final position. This will be your final position. ये बात समझ आई बच्चों? Yes or no? Tell me in the chat. Yep. Yes or no? Do you get this one? आगे बढ़े भाई. Uh, चलो, let's further move ahead भाई. Now, let's move on to the next one भाई. क्या लिखा हुआ है? Point R and T on the string are a horizontal distance of 0.3 meters apart, perfect, and in the position shown in figure 5.4, perfect. बेटा ये point R है, ये point T है, perfect. State the phase difference between the oscillation of points R and T. You have to calculate the phase difference between point R and T. How can you calculate the phase difference between point R and T? always remember, this is another property of a stationary wave. बेटा again and again मुझे notes refer करने पड़ रहे हैं just so that you guys understand everything. If you remember stationary waves में, if you have one point in the first loop, one point in the second loop, the phase difference between both of them used to be 180 degree. ठीक है? Stationary wave में, if one point is in the first loop, one point is in the second loop, the phase difference between both of them used to be 180 degree. Simply, if you see here, this point R is in the first loop, this point T is in the second loop. What will your phase difference be? 180 degree. Simple. State the speed of the progressive wave on the stretched spring. Now you have to calculate V. V is equals to F lambda. Are you given the frequency? No, but you are given the time period. So 1 over time period multiplied by lambda. What was your time period? 0.16. What is your lambda? 0.8. Can you calculate the answer here? Hmm. Any geniuses in the chat who would like to calculate this answer? I think the answer comes out to be 5 ms minus 1. 5 ही आ रहा है? Yes, Alhamdulillah. Is this question 5 clear to all of you? Okay, define Kirchhoff's first law. Okay, what is Kirchhoff's first law, bhai? What is Kirchhoff's first law? Kirchhoff's first law basically states sum of currents arriving at a node is equals to sum of currents leaving the nodes. Kirchhoff's first law basically states that sum of currents arriving at a node is equals to sum of currents leaving the node. Simple as that. Also, you can replace this word of node by junction and it will make no difference. You will still be getting 1 mark. Okay, you can either write node or junction here, no difference in the mark. Let's further move ahead. A cell with internal resistance R perfect is connected to two resistors R1 and R2 as shown in figure 6.1 perfect. The potential difference across R1 and R2 are V1 and V2 separately perfect. The potential difference across R1 and R2 are V1 and V2 separately. The terminal potential difference across the cell is V. The terminal potential difference across the cell is V. The current in the circuit is I. Perfect. Use Kirchhoff law to show that the total resistance RT of the external circuit is given by this. Okay, so you have to apply Kirchhoff's law to show that the total resistance is equals to this. How can you do that? How can you do that? Very, very, very easy. According to Kirchhoff's law, according to Kirchhoff's law, the total voltage in the entire circuit will be equal to V1 plus V2. बेटा ये जो टोटल वोल्टेज है इन द सर्किट, द टोटल वोल्टेज इन द सर्किट, दैट इज ऑल्सो नोन एज व्हाट? The total voltage in the external circuit is also known as terminal potential difference. This V is equals to what? V1 plus V2. Perfect. How can you represent the total voltage? You can represent the total voltage by current into total resistance. How can you represent the voltage across resistance R1? Current into R1. How can you represent the voltage across V2? Current into R2. Can you see current is common across both left and right hand side? R1 plus R2. I cancel out. Total resistance is equals to R1 plus R2. Simple as that. Nothing complicated here. All clear, yes or no? Do you get it? How easy it was to drive this? बहुत easy था भाई. Total voltage in the external circuit is equals to the voltage of resistor 1 plus the voltage of resistor 2. The total voltage is equals to current into the total resistance. The voltage across resistor 1 is current into resistance 1. The voltage of resistor 2 is what? Current into resistance 2. Simple as that. Let's further move ahead. Now let's see what is in store next. The electromotive force is 1.5 volts. Okay, so what are we given? This voltage of the cell is 1.5 volts. Perfect. The values of R1 and R2 are 10 and 15. Perfect. The terminal potential difference of the cell is 1.35. Calculate the internal resistance of the cell. Perfect. So you know a lot of things. You know a lot of things. The voltage across these yellow leads is 1.3 volts. Okay. This is R1 is 10 ohms. R1 is 10 ohms. R2 is 15 ohms. Perfect. Perfect. And the total battery voltage is 1.5 volts. Now, here, if you are a little smart, if you have even an IQ of a fish, you can see that the total voltage is 1.5. The voltage in the external circuit is 1.35. How much voltage is consumed by this small little tiny resistor? How much voltage is consumed by this small little tiny resistor? 1.5 minus 1.35. This equals to 0.15 volts. Perfect. And now, can you calculate the current across the yellow leads? By can you calculate the current? Yes. You know we have a voltage of 1.35 volts. The total resistance is 25. V is equals to IR. V is 1.35. I we have to calculate total resistance is 25. Current comes out to be 1.35 divided by 25. This comes out to be what? 1.35 divided by 25. This comes out to be 0.054. 0.054 ampere is your current. Now, if this current is 0.054 ampere, the current in the internal resistance will also be 0.054 ampere. You have the current, you have the voltage. Can you calculate the small r? Yes, V over I. V is 0.15 divided by 0.054. Can anyone tell me the answer to small resistance R? बेटा R की वैल्यू निकाल सकते हो? Anyone? 2.8 ohms comes out to be your answer. 2.8 ohms comes out to be your answer. Simple as that. Yep. 2.7, 2.8. Yeah, you can say that. Chalo, let's see the next one. A resistor of resistance R3 is added to the circuit so that the circuit is as shown in figure 6.2. State and explain the effect, if any, of this on the current in the cell. Beta, did we discuss this? Did we discuss this? मेरे ख्याल से I have discussed this with you guys on a Sunday. हाँ, I think we discussed this on a Sunday. If you connect a resistor in parallel, what happens? Your total resistance of the circuit decreases. The total resistance of the circuit decreases. What will happen? If the total resistance of the circuit decreases, what will happen? The current will increase. Hence, the current increases. Perfect. Nothing complicated. Now, you have to tell what will happen to the terminal potential difference of the cell. What will happen to the terminal potential difference of the cell? If you focus a bit, if you focus a bit, if your current increases, if your current increases, What will happen? If your current increases, the voltage across the internal resistance will increase. If your current increases, the voltage across the internal resistance will increase. Why? Because V is equals to IR. If current increases, the voltage across the internal resistance will increase. If the voltage across the internal resistance increases, the terminal potential difference will decrease. You can write it here as current increases, the voltage across terminal, the voltage across internal resistance increases, internal resistance increases, hence the terminal potential difference decreases. if is if this is alien to you guys, beta thoda sa samjho. Let's say we have a 1.5 volts battery. Let's say we have a 1.5 volts battery. We initially, this was having 0.15 volts. This was having 1.35 volts. The outer circuit was having 1.35 volts. Inner circuit was having 0.15 volts. But as soon as you increase the current, voltage on the inner side will increase because the current increases. Let's say this becomes 0.25 volts. If this becomes 0.25 volts, the voltage in the outer circuit decreases to keep the EMF of the cell constant. बेटा बात समझ आई नहीं आई बताओ मुझे जरा. यस, चलो भाई आगे बढ़े. आगे बढ़ते हैं यार, अगर क्लियर नहीं है तो बता देना. Nuclei of an isotope copper have 29 protons and 37 neutrons. The isotope is a beta negative emitter. State the nuclide notation in the form of this for the nucleus of copper. Perfect. So you have to state this nuclide notation for copper. Beta, always remember, you have to write the nuclide notation of copper. Always remember, whenever you write the nuclide notation, the protons number come on the bottom side. What comes on the top side? The protons plus neutrons. 29 plus 37 is what? Any ideas, geniuses? 29 plus 37 is 66. 66 over 26 is your final notation of copper. 29, sorry. Let's see this. The energy spectrum of the beta negative radiation emitted by the sample of the isotope is shown in figure 7.1. Take care. This is the kinetic energy variation of the beta negative particle. Use figure 7.1 to explain why other particles apart from the beta particles must be emitted during this decay. Okay. We have to use this figure and tell why other particles must be emitted during this process. Because can you see the kinetic energy is varying? Can you see the kinetic energy is varying? There might be an other particle. And what have I told you? जब भी बीटा नेगेटिव emit होगा उसके साथ क्या emit होगा? Anti neutrino. There might be an other particle which consumes the remaining energy. So how will you write it? The energy of the decay is fixed. However, beta negative particles have a range of kinetic energies. Hence, there might be another particle. There might be an other particle known as antineutrino. Known as antineutrino. which does what? Beta, there might be another particle named as antineutrino which does what? Which consumes the extra energy. Which consumes the remaining energy or extra energy. Chalo, let's further move ahead. State the name of the other particle. What have I told you, beta? बीटा नेगेटिव के साथ हमेशा एंटी न्यूट्रिनो एमिट होता है. Whenever you will see beta negative decay, there might be an anti neutrino. Let's move ahead. The copper isotope decays to an isotope of zinc. Perfect. Give the radioactive decay equation for this decay. Include the nucleon and proton number of all the particles involved. Perfect. Now copper is decaying into zinc. Okay. So copper is decaying into zinc by which process? Beta negative particle decay. So what will happen? 6629 copper will become what? 6630 zinc plus beta negative plus anti neutrino. All clear, yes or no? Tell me the answer. Beta, is this clear? Everything clear? Any ambiguities here?